So hello everybody, this is Mark Sage, the Executive Director of the area. It's April 21st, 2020, and welcome to the latest Area Thought Leaders webinar. Really excited to have you here. I really hope that you and all your family are very safe in our current difficult times. Just before we start the webinar, I'm just going to give a quick overview about the area. Some of you already know, but just as a quick reminder, the area is a global membership-funded, not-for-profit alliance. And we're here, and the members are here to help accelerate the adoption of enterprise AR. And we do that by supporting the growth of a comprehensive ecosystem where these webinars and thought leadership webinars are one of many activities we like to do. Our members are made up of three different segments. We have customers or enterprises that are currently deploying AR. We have a number of providers of AR technology, from hardware, software, consultancy, gesture control, content development, content extraction. And then we also have a number of non-commercial organizations, government agencies, research institutes, universities, and standards organizations. And by coming together and working together, we really are helping to accelerate the adoption of enterprise AR. What we'll do is, and we base this on what we call our four strategic pillars. The first one is about delivering thought leadership, focusing very much on decision makers like yourself. We deliver the kind of information that allows business decision makers to make informed decisions about investing in AR. So anything from the problems that can be solved, the use cases, to examples of those being solved in real life, the case studies, what technologies are needed, and very importantly, the return on investment. And webinars, through social media, through speaking at events, through our portal are ways that you can consume this technology. We also find it's really important to bring the area members together in the wider ecosystem to learn from each other, almost telling war stories and how they've implemented some of the challenges they've overcome, and of course, most importantly, the benefits that's arrived from delivering AR solutions. We want to make sure there's a steady set of skilled workers coming into the industry. So through our Educate program, we're working with universities and educational organizations to help them define courses, to set them challenges, to do guest lecturing, anything we can do to enhance the next set of workers coming into the industry. And finally, we focus through our committees on reducing the barriers to adoption. And that's areas like safety, security, human factors. We meet on a regular basis to discuss some of the challenges and work to overcoming those challenges by creating deliverables, knowledge, and information like that. So hopefully that gives you a good overview of what the area is and what we're doing. Going on a little bit more to our webinar today, you can see it's one of many webinars that we've done over the last 4 years. I do recommend, if you go to the area portal and under the resources, there's a video page. You can go and have a look at that, look at all these excellent leadership and content research webinars. So please feel free to browse and go through those. We've also got podcasts and a whole bunch of other information in there as well. Okay, so focusing on today, and I'm delighted to welcome Theorem Solutions as one of the long-term area members. Theorem was established in 1991, has been an area member for over 3 years. They have a UK head office and also additional offices in Detroit. They have a number of development partnerships with Siemens, PTC, SolidWorks, Dassault Systems, and participates with the ISO standards and STEP, JT, and 3D PDF. Today's Thought Leadership webinar will be led by Mr. David Francis, the Chief Marketing Officer of Theorem, and he'll be discussing how to digitally enhance your workforce. I'll be kind of asking him some questions as we go through, but please feel free at any time to ask the questions on the slide. Ask the questions. I'm sorry, guys. Hopefully you can see my slides. My apologies. Ask any questions in the question box there. So please feel free to answer any questions. So my apologies if you couldn't see any of my slides, but I'm now going to hand over to David, who's going to take us through his presentation. As I said, please feel free to ask any questions in the question box. David, I'm going to hand over to you. And my apologies if you couldn't see my slides. I can see yours.
Thank you very much, Mark. You can see mine. Perfect. Thank you. So that answered my first question. So this presentation is called Digitally Enhance Your Workforce, and it's all about how XR is an essential part of your digital transformation strategy. I'm going to start with a little bit of a caveat to the content of my slides, which is that I have some embedded video. And as I'm sure many of you are, I'm working from home on domestic broadband, and bandwidth is a little bit of a premium. So if their videos are a little bit laggy, my apologies in advance. With that, I shall crack on. So digital transformation and Industry 4.0 are terms that we're currently hearing lots about. New roles have been created in some organizations with these terms forming part of the job titles. But what does an Industry 4.0 person or digital transformation person actually do? What is Industry 4.0? And surely we're already digital, aren't we? We've got smartphones, virtual reality, more computing power than it took to put a man on the moon on our wrists, with things like Apple Watches and Fitbits. We even have a smart refrigerator. So how much more digital is there? So we already have all of these things I've just mentioned. The process to create many of our everyday goods is still very much in the 20th century. The first industrial revolution introduced mechanization through the use of water and steam powered equipment. The second introduced mass production and assembly lines that were powered by electricity, whilst the third introduced computers. The fourth builds on this with concepts such as a smart or a connected factory. The smart factory uses technologies that rely on big data, which is complex information that traditional data processing applications are unable to manage effectively. Through the implementation of technologies such as blockchain, the Internet of Things, and artificial intelligence, computers and automation can enhance the manufacturing process with smart and autonomous systems powered by data and machine learning. Smart factories use the internet and the cloud to connect the real and virtual worlds, resulting in the seamless integration of cyber-physical systems at all levels. This allows the whole production process to be monitored. When computers were introduced, it was highly disruptive due to the addition of an entirely new technology. Now and into the future, computers are connected and communicate with each other to make decisions without human involvement. Until such time as we can rely on machines to operate completely unattended, assuming that this is something we want to do. We've all seen the movies like The Matrix and The Terminator, and these will perhaps have us believe that it's probably not a good idea to allow machines to operate without us. So there is always going to be a need for this cyber-physical relationship. And so in order to bring us into the same playing field as machines, let's make it easier for us to consume information. This is where extended reality technology comes into digital transformation strategy. And this is how you integrate the human being into your 21st century processes.
So David, let me just ask a quick question there. Can you talk perhaps a little bit about the companies or industries are delivering great examples of Industry 4.0 environments?
So Industry 4.0 at the moment is still, I think, perhaps a hypothetical or working towards. There aren't really any companies that can say that they're fully Industry 4.0 or have done a digital transformation project and are now fully digitally transformed. It's all something that they're aiming to achieve, and many companies have started this journey, but I don't think anybody could say, yes, we're Industry 4.0. But there are some things that we can do quite easily now. For example, a digital twin is entirely possible. And I actually will cover that off in a couple of slides' time. There are many benefits to this digitization. It can save money, you get faster delivery, increased safety, which is again something else I'm going to cover as well. So hopefully I answer this a little bit better as we progress through the presentation.
Fantastic, thank you.
So first we need to understand how we can best consume information. A combination of the technologies mentioned on the previous slide make Industry 4.0 possible and the smart factory a reality. As a result of the support of smart machines that constantly get smarter as they get access to more data, factories will become more efficient and less wasteful. Whilst machines can cope with all of this big data, these factories are still today overseen and operated by people. The average person cannot compute this level of information, so processes need to be implemented to humanize what is going on around us. The human brain works in an entirely different manner to a computer, and in order to gain the best value from the necessary information it needs to be placed in context with its natural environment. We did an earlier white paper a year or so ago, which was called Closing the Cognitive Gap, and that looks at that in detail. However, to summarize this in just a couple of lines, the human brain works in 3 dimensions. Therefore, it's unnatural to ask our brains to process 3D information that is not in context and at full scale. Shrinking information onto a 2-dimensional display creates cognitive load, which is the mental effort required to process any given type of information. Our engineers are restricted to having to view their work through a 2-dimensional window, which we all know and recognize as a computer monitor. So in order not to decrease the productivity of your digitally enhanced manufacturing process, you need to digitally enhance your workforce. And we achieve this through extended reality.
Sorry, David, I was going to ask a question there, and it's great to see that you have the area infographic there. Can you talk a little bit and highlight some of the kind of key considerations and best practice in delivering solutions with the appropriate cognitive load?
It's really important, I think, to understand the use case in order to best answer this. I've got some slides later on that will look at some of the specific use cases that we look at Theorem Solutions. But a good example would be, I think I was talking to someone a while ago who's a military contractor who's developing solutions for people working in the Navy in this particular example. And they were really struggling to understand 3D CAD through this 2-dimensional window that I spoke about a couple of moments ago. To understand data just on a computer screen is completely foreign to them when they're used to operating in things like ships and aircraft carriers. So in order to be able to provide that information using technology like virtual augmented reality to make it full scale and to put it into context, i.e. you're now standing on the deck of this vessel, means that they can understand what they're seeing. To see it shrunk down on a computer screen is unnatural for them, and they just don't understand it. And as you just pointed out, the cognitive load is, of course, one of the topics which is being researched by the Area Safety Committee. So it's definitely something that really requires a lot of thought about.
Definitely, we've seen examples of too much kind of experience or too much cognitive load, making it very difficult for people to process what they're seeing as well. So you get both extremes, difficult to compute it on a 2D screen, but also too much in a 3D environment as well. So you're right, it's all about the kind of use case and the problem that you're trying to solve, and that needs to be carefully thought about in any design of a AR solution.
Absolutely, it goes back to my earlier point as well, which is just because a computer can handle that much data doesn't mean that the human brain can.
Yeah, correct. Okay,
thanks for the question. So I've talked a lot about extending reality, which is the umbrella term for augmented, mixed, and virtual reality. So here's the first time I'm going to try and play a video. Apologies if it's to design your smart, as you can see here, virtual building value. A good example of mixed reality would be to holographically project via a headset like the HoloLens or Magic Leap the virtual object into a real world setting, which you may need to go to check that something will fit into a space or that it'll interface with the equipment around it. Augmented reality, in our definition, helps provide additional context to the real world. For example, overlaying CAD and its associated metadata onto a real world assembly. I said our definition there because it's quite important to understand that some people consider augmented reality to include both what I've just described as augmented reality as well as mixed reality into the same thing. The whole topic is really open to debate as to what is AR and what is MR. The important thing, though, is that all of these essentially do the same thing. They provide 3D content in context with the environment in which they're to be used. They make it so that the human brain can actually be comfortable and understand what is going on. Data in context is really important and was recognized by Leonardo da Vinci, who once wrote, "A poet would be overcome by sleep and hunger before being able to describe with words what a painter is able to depict in an instant." This is considered to be one of the origins of the phrase, "A picture is worth 1,000 words." And maybe a 21st century version of that could be images in context are far more easily understood than data that is not. So having accepted that it's appropriate to start looking at XR as part of your digital transformation strategy, there are some things to think about. It's commonplace to begin with a proof of concept project with an in-house department. The great thing about this approach is that something tangible can set up really quickly, particularly as some of the games engines from Unity and Unreal Engine lend themselves to this task. However, you should be mindful of what you're trying to achieve, as it is easy to create some technical debt. The problem with the proof of concept is that invariably it will not be scalable. It will be the one particular project, but if you wish to roll out the XR capability, then you find yourself having to do a lot of rework. Therefore, there's a significant one. Which you can see here really quickly into an XR experience. So you need to consider where all your digital assets come from and how you get them in there. There are some fantastic examples online of some really high-end video content showing the art of the possible. But many of these videos are examples of someone having spent days or weeks in graphic studios creating something that looks really good. But if you dig below the surface, you'll find that some of the content isn't really there. Often the graphics have been carefully created by a graphic artist or 3D modeler in a product like Autodesk's 3ds Max, which is brilliant if you want to create a promo video, but not so helpful if you want to create a scalable enterprise-grade process. So having a process and the underlying technology that will allow you to reuse the digital assets that were used to design the products in the first place will definitely help. So I mentioned technical debt a few moments ago. What do I mean by that? Technical debt describes what happens when software development teams take actions to expedite the delivery of a piece of functionality or a project which will later need to be reworked. In other words, it's the result of prioritizing a quick win over a perfect solution. If technical debt is not repaid, it can accumulate interest, making it harder to implement changes later on. Technical debt is not necessarily a bad thing, and sometimes, particularly if you want to do a proof of concept, it's required to move the project forward, but you can encounter problems down the road. For example, by creating a POC in-house, you rely on the skills of your staff members. If the business restructures, you may find that these resources are no longer available. So who will continue their work and move it on to the next phase if they're not there? There are many reasons you could find yourself in the situation of creating this technical debt. This technology is so new, it is quite possible there was insufficient upfront definition. Often requirements are still being defined during the course of the project. Agile delivery is all about iterations and rapid delivery, but this often means that the solution has to be reworked later. Business pressures, where there's a concern that not doing something will lead to a competitive disadvantage, leads to something being released sooner before all the necessary changes are complete. And this builds up technical debt, comprising those uncompleted changes. Or you could have a lack of process or understanding of the desired outcome. Businesses are blind to the concept of technical debt and make decisions without considering the implications. Some issues that we've encountered with our clients include not thinking about what will happen when your CAD vendor no longer supports the version of software that you're using. Your processes are absolutely dependent on your 3D CAD and your ability to integrate it into virtual or mixed reality or augmented reality, but your solution is now end of life. So your approach needs to be governed by your use case. In some instances, the off-the-shelf products which has been made by experts in 3D CAD is the right way to go. But for other use cases, as long as you can get your 3D data into the games engine, then building an experience yourself is not a bad way to go.
Yeah, thank you, David. It's one thing we talk a lot about in the area. And can you kind of summarize a little bit about considering we're moving from a proof of concept to full deployment? We know that many companies struggle with this kind of step. Have you got some other advice or thoughts on how to do that successfully?
I think the first thing you need to do is make sure you're actually solving a problem. Lots of times people want to start a proof of concept just to be able to show that they're doing something. But if it's not actually solving a business problem, then are you really wasting your time? You also need to think about the safety of the people involved, especially those who will be using the product, not just those involved in the actual project. The other thing you really need to think about is that you're invariably going to be disrupting probably an absolutely fine business process. It's not just a technology project, it's a change project. You're fundamentally changing the way that you do something. So to think about all of the stakeholders who are involved in that process, they need to be involved throughout to make sure that they're actually bought in and engaged. Speaking of changing a process, I think what a real biggie to think about is actually your PLM. Many organisations have had robust and well-established product lifecycle management process in place for many, many years. The great thing about PLM is it properly manages everything that's around the product that you're creating. You create your design, it's checked in and checked out of the PLM system as they and all of the associated metadata to that product is carefully tied together so that throughout the entire product lifecycle, everything is kept where it should be. But along comes this potentially disruptive force that is XR, and as the PLM manager, you're carefully controlling all this data that relates to your company's products. And then suddenly there's this new department that's popped up doing this proof of concept or maybe something slightly bigger, and they're asking for CAD models, which they want to take outside of this process. And to make it even worse, they want to create new digital assets from this CAD to use in an XR experience. So now, as the PLM manager, how can you possibly be in control of this? There are solutions that can connect to the PLM system and check out the CAD model, so that other users are aware that the product or an element of it is being worked on. And in fact, our visualization pipeline product can do just that. So if you're using Theorem XR, following an immersive design review, the associated media, notes, photos or videos can be saved and returned to the designer. So maybe not all is lost. Possibly, but unfortunately it's more complicated than that. These new digital assets have been created and used for a process, and information as an output from this have been documented, but this cannot be checked back into the PLM system. Unlike with CAD data, where there's a CAD manager that knows exactly what it is looking at, there's currently no XR asset manager. Therefore, the PLM doesn't know what this new type of asset is, nor what to do with it. So an important thing to consider before you start to implement an XR solution is whether you've identified all of the other processes, engaged with all of the other stakeholders before you implement something that is highly disruptive. In the case of your PLM process, until such time as someone's created an add-on that will manage your new XR assets, these will need to be managed outside of this process. But this doesn't mean you shouldn't adopt XR. So over the last couple of slides, we've looked at digital assets and how you can reuse what you already have. Some considerations around technical debt to your organization. And on this slide, how XR is a disruptor to your PLM process. Now, it may have put you off, and you may think, well, I don't think I'm going to bother doing all of this. But the thing is that working at context and at full scale there are huge benefits. And many of companies that have implemented this will tell you about their ROI. And one of ours, who is NCR, or National Cash Registers, who are one of the early adopters of our XR toolset, they've been able to make projected savings of almost £400,000 in the first year. And they're expecting to see a full return on investment in just 2 months. So if you can make that kind of a saving, then surely it's worth having a look at your processes. So earlier on I mentioned that we'll have a look at the digital twin. And to be fair, a piece which talks about things like digital transformation and cyber physical systems would be amiss without talking about it. And again, this is another term that's generated lots of buzz over the last few years. And again, it's synonymous with this Industry 4 language. But what is it? Digital twin is a digital replica of your real world environment, which allows you to monitor, model, and simulate activities as if you were working with the real life counterpart. It is the twin of the real world. Invariably, as it is a twin of the real world, it must be three-dimensional. This means that it must be based on some kind of 3D asset, and therefore originate in the world of 3D CAD. A digital twin is more complex though than just the 3D data with its metadata. It requires a link to the other Industry 4.0 technologies that I mentioned earlier. For a digital twin to be fully effective, it must respond in the same way that its real life counterpart would. Therefore, links, probably via web services, to IoT or blockchain technologies is a necessity. For example, if there's a sensor in your equipment that is alerting you to an issue, then this should also be identifying the same issue in the digital counterpart. This is important, as if the maintenance crew are off-site, then they can see in the digital twin what the problem is. It could be particularly useful in something that is usually unmanned, for example, an offshore wind turbine. By having the digital twin alerting you to this problem, your engineer can look to see how to resolve the issue before they set off. This means that they will have the correct tools, and if they need spare parts, making sure that they have these too. If this activity is something that might require rehearsing, then a digital twin can also be used to achieve this. Unlike the real asset, which might be in a hazardous environment, if we stick with that same example of the wind turbine, your asset could be somewhere like in the North Sea, then the fact that the engineer is fully ready is hugely important. Not only will this prevent unnecessary repeat visits, but it also means that it will be safe and they won't cause damage to themselves or your incredibly expensive asset. The benefits to this are quite significant. You can improve your knowledge transfer, especially if you've got an aging workforce. You can become effective in the field right away with guided work instructions. You can use it to reduce service costs, as your service instructions are now much more easily maintained. You can increase service revenue by fixing things faster and first time, which can lead to better customer satisfaction and potentially upsell opportunities. The connected worker is another one of the areas that we've been looking at. Our guides experience allows the user to be trained on the maintenance, assembly or disassembly of a product in either virtual or mixed reality. Coupled with our CAD overlay capability, which you can see in the photo on the screen, where you can snap digital geometry to the real life counterpart. Microsoft have conducted research which has found that staff that have been trained in complex tasks using technology like the HoloLens have been 25% more productive than those that have not. And additionally, due to the collaborative properties of the device, they've found that 80% of companies that implemented mixed reality said that the collaboration across their cross-functional teams had been improved. To wrap up the thoughts on the digital twin, there's still one other way that 3D visualization can help. In addition to managing the asset and training staff to work on it, you can also use your digital twin to provide remote assistance. This is where an expert who is remote to the person with the issue that needs resolving can provide remote support. By using the cameras on the device that they're using, they can provide assistance to the field-based user. This is like using a WhatsApp video call or Facebook on steroids, because rather than it just being a video call, it's now got access to all of the other data that is connected to that digital twin. So how can Theorem Solutions help with your digital transformation strategy? So we've worked in the world of 3D CAD for almost 30 years. It'll be 30 years next year, in fact. It is this 3D foundation which is the cornerstone of Industry 4.0. So providing innovative solutions to assist with this new connected digital future was a logical next step for us to do. And it was through the appreciation that a person needs to have their data in context and at full scale to fully understand it, and not to introduce this cognitive load, that led to the creation of Theorem XR. Unlike other XR companies, we initially focused on the important matter of getting your 3D CAD assets into your XR experience in a simple and efficient manner. To achieve this, we developed the visualization pipeline, which is a server-based technology which can support drag and drop of your 3D CAD, as well as being connected to your PLM system like I described earlier, which is really important because you can check out your CAD model. It operates by using our CADverter technology, which is what we've been developing for nearly 30 years. And many of the OEMs in manufacturing have been using this to translate their 3D assets from one format to another for many, many years. And this has huge benefits in that it helps improve collaboration throughout the supply chain, and therefore makes your production processes far more efficient. We designed this to optimize the output for all of your visualization workflows, whether you want to put your CAD into a cave or a power wall, or whether you want to put it into photorealistic rendering, lightweight viewing like JT, or whether you just want to create an asset to put into your XR experience like Unity or Unreal Engine. What's unique about the way that we do things as well is, as Mark said at the beginning of this, is that we have these partnerships with PTC, Dassault Systems and Siemens, and we use their vendor APIs, which means that we're not reverse engineering the 3D CAD. We're actually using the APIs from the CAD vendors themselves, which means that we have a much higher chance of converting the data exactly as how it was intended. If it's been reverse engineered, then you've got to rely on the fact that the person that's reverse engineered those APIs has got it right, and also the fact that they've got the latest APIs. The CAD vendors update their CAD very frequently, and because we've got partnerships with those vendors, it means that we get access to that information, whereas someone who's reverse engineering won't. So after initially thinking about how to get 3D CAD into XR, we then started looking at the technology underneath it, and realised it's very much limited by the available hardware. Head-mounted displays are now very cost-effective, and the image and resolution and field of view are all improving all the time. However, workstations to power them can be very expensive. So we adopted the Unity games engine, which exploits the power of the gaming range of graphics processors, as these are optimized for this use and are significantly more cost-effective than the really high-end professional-grade equivalents. Adopting this hardware approach meant that an entire solution could be bought in at a much lower price point for the consumer. Unity for us was the obvious choice, as 60% of all XR applications are made with Unity, and it has the additional benefit of all of the majority of the hardware devices supporting Unity out of the box. So due to this decision on the choice of technology wrapper and the associated benefits of the hardware that is delivered, we then realized that we needed to optimize the data. In a large scene, particularly a factory layout, the user will be loading many different models, which may well have a full product tree included as part of the assembly. In some instances, this level of data is unnecessary. Furthermore, the need in a design review to interrogate an assembly right down to the very last nut, bolt and washer might also be overkill too. So our software development team introduced features to make this more efficient experience. So some tools to collapse the hierarchy, shrink wrap and part cull were introduced. So by having the models in your scene that are too heavy, the user experience is negatively impacted. The result is a laggy experience, which is uncomfortable for the wearer, with frame rates, refresh rates becoming low, and this can result in VR sickness, which is where the physical motion and the rendered scene become out of sync, which confuses your brain. So in developing the pipeline, we were really keen to mitigate against this, which is why we created these options at the point of file conversion. The biggest issue with XR today is that it's a constant fight for the best compromise. In an ideal world, you'd tick, I want the highest quality, I want all product tree, you tick every option that exists. But there's only so much computing power available. And if you're using a mixed reality headset, like a HoloLens or a Magic Leap, the computing's done on the device. So therefore, you've got even less computing power because you're not attached to a big, powerful workstation. A key component of our CADverter product line is the ability to provide collaboration around a 3D asset. Being able to translate it into a format that's used by the supply chain means that collaboration around the design is far more easily achieved. However, this data, whilst 3D, is still displayed on a 2D monitor, so to really benefit from the design concept, a 3D approach is necessary. Kind of collaboration which led to Theorem regarding the world which device. The location element is of significant importance. With supply chains rarely being located in the same city or even country, it is really important that these teams can collaborate around a design regardless of where they are. Hosting a collaboration session on the visualization pipeline server, our users can join a session and participate in the review regardless of where they are. They will appear, as you can see in the video, as an avatar, and this represents their location with respect to the 3D model and shows the other users what they're looking at. The control can be passed to anyone in the session, not just the person that set it up, so ideas and thoughts can be shared. The second point is that we're not restricting this ability to collaborate to just VR users. Mixed reality users can also participate in the same session. So if you've got a HoloLens 2, a Magic Leap, you can join in a session with those who are working in VR. And again, your avatar appears in exactly the same way. Again, in context and in relation to where the 3D model is. So regardless of your device, anyone can join in with an immersive collaboration session. If you don't have access to an MR VR device, then you can still join in by desktop. However, in doing so, of course, you will be back to viewing the world through a window, i.e. your computer screen. Of course, because of the unfortunate situation that we're currently in, with people working remotely or stuck at home, this collaboration has never been so important. So having developed the architecture to effectively manage and handle 3D assets, as well as the ability to collaborate, we decided that we needed to think about why you might be wanting to work in full scale. So unlike other product offerings, we looked at detail at the features that are required for each use case, and we provided just those that are necessary, whilst omitting a full feature set, as it was felt that consumers do not want to pay for features that they'll not be using. This has led to a portfolio of XR experiences which do exactly what the user needs. We have 5 of these. We have a basic immersive visualization experience, design review, factory layout, guides, and an app for inspections. I'll quickly whiz through what we can do in each of these. Really 3D full scale assembly, full sizes of different components, how it interfaces with the environment around it. There are a few more additional tools that we've added to this as well. So you can, as you can see in the video, we can hide components, we can do dynamic sectioning, we can revolve and rotate the product as well. The desktop version of this experience is actually bundled with our visualization pipeline, and very shortly we'll be including this with our CADverter products too. A design review is another one of our experiences, and this is a formal process, and it's a free, as this is an exercise, we've set a set of specific with the, and these are focused in a collaborative, as you don't generally do a design review by yourself. It's also really important to be able to document the content of the design review. So in documenting it, we provided 3 options. You can do written notes, video clips, and record images. The ability to leave written notes in XR has always been a bit tricky. Those of you who've been lucky enough to try a HoloLens 2, however, with the virtual keyboard, have found that it's a whole lot easier to start to type now. The same sort of experience can be found with some of the Vario headsets as well. Sometimes, though, typing isn't enough, so to be able to grab a screenshot or to record a video clip is really useful. And it makes it so much easier for the designer to understand when they're back at their desk, being able to review the image or a short video clip to remember what was discussed. This experience includes all of the core features from the visualization experience. So all of the stuff you saw in the earlier video, all of that remains. The factory layout experience provides you with all the functionality you need to optimize factory layouts through immersive visualization. Creating new layouts can be expensive and disruptive, so prototyping a concept in Theorem XR makes the process more flexible, modular, and easy to reconfigure without the traditional expense. Your existing or new library components can be imported and repositioned using grab and move capabilities with our simple snap tools you can see in the video, hopefully, for easy and accurate object positioning. If you want to look at the entire factory, you can shrink it down to tabletop view, as you can see on the screen at the moment. And this is really useful when you're using a HoloLens, because to load an entire factory in a HoloLens can be quite a lot of data. So it's quite difficult to see it at full scale. And due to the need to appreciate the surroundings, such as the building, we've introduced some additional input formats, including Revit, MicroStation, and we can also now do point clouds in E57 format. So all of those can also be imported via the pipeline. Our CAD overlay application provides the ability to see the original design overlaid on top of the physical component. So this allows a user to use their physical prototype, check it against the original 3D design, prototype like video, or provides object support. So in addition to looking at 3D geometry, you can see the actual object underneath it. The CAD overlay app will also work with any CAD model which has been uploaded to the pipeline. So unlike other applications, this is not a one-off or a hard-baked experience for a single product. So it's really easily scalable and ready for an enterprise-level rollout. And this application will run on most common mobile platforms, allowing current devices to be used without the cost of having to purchase more equipment. Our guides experience provides production operatives the ability to optimize your processes and accelerate production readiness through XR. The 2D content and link it to a 3D Theorem XR content. The content can be a series of steps or stages, and each step, when played out, will display the 2D content attached to the 3D geometry. Guides provide 3D content at full scale and in the context of the physical parts, as you can see here. And you can do this in virtual reality, mixed reality, or augmented reality. It also has the ability to replay animations, and here as well, you can even include a video of the real world process. So you can see exactly what it is you need to be doing as you then rehearse it in the VR. A bonus feature is you can do this in conjunction with CAD overlay, I showed a moment or two ago, where the digital geometry can be snapped to the physical item. So therefore, you can have your training guide showing you how to assemble the actual item with the instructions and digital markers pointing at the real life objects rather than just a virtual representation. And those markers can give instructions to tighten or undo, remove, replace, all of the different things that you might need to do. So Theorem XR is a suite of experiences for specific use cases with features that are required to deliver the benefits that our customers need. We developed it to digitally enhance your workforce through providing our customers with the information that they need at full scale and in context to perform their tasks in the most efficient way possible. We developed our solution on the premise that not one CAD vendor or headset or output device is the best at everything. Being CAD vendor neutral, as we have always been, remains a core value to the way we operate. So we carried this approach over to our XR devices. We will work with VR headsets from HTC, Oculus, and several others. We'll also work with mixed reality devices from Microsoft and Magic Leap. So why have we done this? Because the choice of device is based around two things: your use case and your personal preference. So we felt that us as a software vendor shouldn't force you to choose one over another. As you start to look into the world of Enterprise XR as part of your digital transformation strategy, make sure that you consider which problem you are looking to solve and make sure that the solution can deliver the benefits that you need to achieve. As you do your analysis, if a video that you see online looks too good to be true, with experiences appearing really real, then quite possibly it isn't true, or at the very least scalable. Graphic artists can create amazing scenes using rendering technologies, but often these are one-offs which can't easily be replicated. However, if you've uploaded your digital asset to the Theorem XR visualization pipeline, then you can use it in any of our experiences. And if you change the design, upload the new CAD model, or our system will check it out from your PLM system, and then the XR experience will provide the full scale in context again and again. Theorem XR is a truly enterprise solution that won't lock you down to a particular 3D CAD system or a specific device. We will help you be Industry 4.0 ready and gain that competitive edge over your competitors.
Cool. Thanks so much, David, for that insight. Sorry, are you finished?
Yep.
Yep, cool. Just remind the people listening, please ask any questions in the questions box. I've got one last one before we open it up to the type questions. I'm a big fan in the area, a big fan of focusing on the use cases, problems that need to be solved. So can you talk a little bit about which ones you're seeing most popular in the ecosystem or with your customers at the moment? Talk a little bit about that. Which ones are you seeing most traction?
Yeah, so our customers have got varying problems. So therefore, obviously, as our experiences are use case focused, there's a myriad of different things out there. But I think the one that most people are finding to be the most useful, particularly in the current climate, is design review. And that's because it's a collaborative experience. And the ability to be able to collaborate from anywhere in the world with whatever device you've got, including your desktop, I think is incredibly powerful. You can bring together, I think it's about 30 people into a single session, say anywhere in the world, really easy to set up, and you just get a link straight into it. And to be able to work like that is paying dividends.
Perfect, thank you. Let me just have a look here. Got a question. Again, please, people, feel free to ask any questions. Do you use large screen stereo projection for multiple team design reviews rather than headset immersion? Is that something you've done within?
Yeah, so we don't provide hardware. So our view has been that we would try and provide our solutions to whatever technology people want to use, which is why we've got this sort of neutral approach. As it happens, we haven't got any customers right now that have asked for large screen projection. However, I'm aware of organizations that do have projection systems that they've got Unity-based experiences running on them. So I can't see it being a problem. Just right now, we haven't got any customers that have asked for it.
Okay, thank you very much for that. Okay, is there any last questions? Okay, thank you very much for attending. We will be making this webinar available on the area portal as well as YouTube. So just thank you, David, for that really interesting insight. Thank you. Oh, hang on a sec. Looks like we've got. Okay, I think Peter may have to come back to you on that. So I'm going to kind of close down the session. Again, thank you very much, David. Please, everybody, stay safe out there. We will be having more area webinars. If anyone's got any ideas or content they'd like to hear about, please feel free to contact me at mark@thearea.org. And I wish you all safe, and thank you very much for attending today.
Thanks,
everybody.
Goodbye.
Thank you. Cheers. Goodbye.